Back children, today we are going to discuss word problems of application of derivatives. As you know, word problems comes in 6-marker question in your board exams. Children, you can earn this 6 marks just by remembering few steps. As you'll do the questions, you need not to remember all these points. Now see, what are these points over here? First of all, it is given, draw the diagram. So, whatever is given in the question, you draw the diagram for it. Children, remember, your diagram can also fetch you the marks for the given question. Secondly, you frame the equation or formula of what is given to you in the question. Thirdly, you need to find out f dash x. Then, to maximize or minimize it, you need to do f dash x equal to 0. You will get the critical points. Now this is the point where you need to find out the second order derivative, which will conclude whether the critical point which you have got here will give you a maximum value or a minimum value. Children, if your second order derivative comes out to be less than 0, then you will get a maximum value. And if it comes out to be a positive value, then you will get a minimum value. Look here, f double dash if comes out to be negative, that means you will get a maximum. That means function has attained some maximum value and then it is decreasing. Then it has started decreasing. If it gives you a positive value, that means you have attained minimum value somewhere and then it has started increasing. So here the signs are just opposite. Negative value means maximum, positive value means minimum. Then you need to just put your critical points. Once you have concluded that the value is going to give you the maximum or minimum value, you have to put it in the function and find that maximum or the minimum value. Now let's see how we can apply these steps in the given question. Children, first of all, we'll take simpler questions and then we'll move to complex questions. Look here, it is given, find two numbers whose sum is 24. So let two numbers be x and y. Now what is given to you? Sum of two number is given to you as 24. So this is the equation framed, and whose product is as large as possible. So product you need to maximize. You need to find out this. Now you know that product is given to you. You can frame the product here as x into y. So whatever you need to maximize or minimize, convert this into one variable. So I will be converting into one variable by using equation 1. So y can be replaced here with, y can be written as y equal to 24 minus x. So I can replace y with 24 minus x over here, which gives me 24x minus x squared. So here diagram is not required. I have framed the equation. Now I will be differentiating it. So p dash x will give me 24 minus 2x. 2 I can take common. So this is 12 minus x. Okay. Now if I want to calculate critical points, then p dash x equal to 0. So here after putting this, so I will be getting it as x equal to 12. Now this is the value, this is the critical point which I am getting. Now this value will give me the maximum value or not. I will check it by second derivative. So for this I will be calculating my second derivative. So this is my first derivative. So I will differentiate it again. 24 is 0 and here it will be minus 2. It is coming out to be negative. That means this p double dash x, when comes out to be negative, you will get a maximum value. That means you will get a maximum value at x equal to 12. So I will be putting this over here, or I need to maximize p, maximize as I need to maximize my product. So I need to find out the value of x and y. So if my x is 12, I will be writing it as p double dash x is negative, so it is a maximum value. It is a maximum value, and I will be putting x equal to 12 is calculated over here, so y will also be equal to 12. So your product will be maximum if your x is 12 and y is 12. See this question, children. You are given a square piece of tin. So say this is your square piece of tin. 18 centimeter is to be made. This is 18 centimeter made into a box without top by cutting a square from each corner. So we need to cut square from each corner and folding up the flaps to form the box. So you know box is in the shape of cuboid. So we need to find out here length, breadth and height because we are framing the cuboid box over here. Fine. So let the side of the cut off square be x. So now children, when these are folded upwards, then what will be the length of this cuboid? Here it is cut as x and here also it has been cut as x. So it will be your 18 minus x. So that means your length is 18 minus x. What about breadth, children? Your breadth will again be 18. From here and here it is cut as x. So your breadth will again be 18 minus, not x, it is 2x. X from this side and x from this side. So it is 2x. So again this be 18 minus 2x. Now what will be the height of the cuboid? You are folding the x corner. That means this is the square which you are folding, and this is of height x. So height of your cuboid is x. It is centimeter, centimeter, centimeter. So I am writing it centimeter. Fine. Now what should be the side of the square to be cut off so that the volume of the box is maximum? I need to maximize the volume. Okay. So here I am known to my length, breadth and height. So I know volume equal to L into B into H. So I can put all these values, 18 minus 2x into 18 minus 2x into H. So this is my volume. Draw the diagram. This we have done. Frame the equation of formula. Yes, we have framed. Now differentiate it. So we'll be differentiating this volume with respect to x. So this is u into v into w. So I'll be differentiating this. So this will be just minus 2, and then the formula is differentiate this, put these as it is. So this again plus differentiate the second and put these as it is. So 18 minus 2x and x as it is, and differentiation of this is again minus 2 plus put these as it is. So this will be 18 minus 2x whole square, and differentiation of x is 1. So this is my v dash x. Now open, or I can take 18 minus 2x common out of it, and internally I will get it as minus 2x plus, again minus 2x and plus 18 minus 2x, which will give me 18 minus 2x. This will be your 6x minus 6x plus 18. So this is v dash x I am getting. Now to get the critical point, I need to equate this to 0. So if I equate it to 0, I will be getting two values, 18 minus 2x equal to 0 or 18 minus 6x equal to 0. So I will be getting over here as x equal to 9 and here as x equal to 3. So these are my critical points. Now to find out whether these value will give me the maximum or the minimum, I need to conclude this from second order. So let's differentiate your v dash x. So this is my final step of first derivative. So I'll calculate my v double dash x from here. So I am differentiating it again. I'll be getting it as minus 2 for this and minus 6 for this. So I'll be getting it as plus 12. That means I am getting this here is in product, so I'll be applying product rule here. So this is minus 2 over here. Differentiation of this 18 minus 6x as it is plus 18 minus 2x as it is. The differentiation of this will give me just minus 6. So I will be getting it as minus 36 plus 12x minus 108 plus 12x. So here this is giving me as 24x minus 14, 4, 1. So now you see children, I am not getting this value as positive or negative. So what I need to do, here I have got two critical points and I need to maximize the value. So once I will put x equal to 9 and I'll see whether this is giving me a positive value or a negative value, then I will put 3. So when I am putting y, or I can say at x equal to 9, then I am getting it as 24 into 9 minus 144, which will give you 36, 216 minus 144, which is greater than 0. If it is coming out to be greater than 0, that means you will get a minimum value. But I need to maximize it. That means at x equal to 9, I will not be considering because it is giving me a minimum value. I will be taking this for, again, at x equal to 3. That means here 24 into 3 minus 144, which gives me 4 3s 72 minus 144, which is giving me less than 0 value. That means your volume will be maximum at x equal to 3. That means this will be rejected and this will be considered. So at x equal to 3, your volume will be maximum. So you will be calculating the volume, maximum volume when you want to calculate. Put x equal to 3 here. So it will be 18 minus 6. Again 18 minus 6 into 3. Now you just find out 12 into 12 into 3. So this is 144 into 3 and your volume will be maximum. 4 3s are 12, 30. Your volume, maximum volume can be of 432 centimeter cube. Now let's see this children. This question has come in 2002, 2006, 2008, 2011 and 2013. That means from board point of view, this question is important. Let's see how to solve this question. It is given here, show that of all the rectangles inscribed in a given fixed circle, so let this be your fixed circle, and there can be many rectangles of different length and breadth. We can inscribe any rectangle in this circle. So let's say this is your rectangle which is inscribed in the given circle of radius say A. This is radius A. Okay. In a given fixed circle, the square has the maximum area. That means this rectangle, when it becomes a square, that means this side when becomes equal to this side, then it will have the maximum area. We need to prove this. That means we need to maximize the area over here. Now let's take this length as 2x, let's take this breadth as 2y. Okay, so let A, B, C, D, I can write, let A, B, C, D be a rectangle inscribed in a circle of radius R, and the length and breadth of the rectangle be 2x and 2y. Okay children, so these are the things we have supposed. Now you need to see that we can form a right angle triangle if I take it as a midpoint. So if this complete is 2x, this is your x, and say this is your center point, so this be your y. So when I can apply Pythagoras theorem, so I can take it as either I can make this triangle over here, or simply I can make it on the base like this. It will be more easier to understand. So let this be O, R, this be X, and this be Y. Take this point as say E. So in triangle AOE, I can apply Pythagoras theorem over here. So x square plus y square equal to r square. So I can write it as in triangle AOE, x square plus y square equal to r square. Fine. Now we need to maximize the area. Now area can be written as area of a square is length into breadth or side square, because I am taking here rectangle, so I am saying it length into breadth. But if I want to maximize my area, and if it is a rectangle, then it will be L into B, which is length is given to you as 2x and breadth is given to you as 2y. So this is 4 into xy. I need to maximize my area, and I told you that whenever you are maximizing anything, you need to frame into single variable. So let's see, are we going according to these steps? Draw the diagram. So this is the diagram. Frame the equations. So we have framed the equations over here of what it is given. Differentiate the value. Now first of all, I'll converting into one variable and then I'll be differentiating. So this can be written as 4x. Y can be written from here as under root r square minus x square. So here y can be written as under root r square minus x square. So this is my area. Now let's find out a dash with respect to x. This is in product u into v. So I'll be differentiating it. So this is, say, this is a number. So as it is, differentiation of x is 1. So I'll get r square minus x square as it is. Then plus 4x as it is. I'll be differentiating this. So it will give me root x will be 1 upon root r square minus x square, and differentiation of this will be again minus 2x. So here I'll be getting it as 4 under root r square minus x square minus 8x square under root r square minus x square. Now get the critical points by making a dash x equal to 0. So make it a dash x equal to 0, you will get it as, make it equal to 0, take the LCM, so you will get it as 4 r square minus x square minus 8x square equal to 0, or I can get 4x square, this is x square minus 8x square equal to 0, or I can take this as, this is minus 12x square plus 4r square equal to 0. So this is the value I am getting over here. So here after calculation I have got my x equal to r by root 2. So this is your critical point. Now we need to check whether it gives me a maximum or a minimum value. For that I need to find out my second order derivative. So for second order derivative, you need to differentiate this further. You need to differentiate this further. So differentiate it further, and after differentiation you will get it as, children, here you calculate it in u by v form, simplify it in u by v form and apply the quotient rule over here. Then after application of quotient rule, I will get it as this. Now you check whether this second order derivative at x equal to r by root 2 is giving me a positive value or negative value. It is giving a negative value over here. That means I will be getting my maximum value at x equal to r by 2. Now if x is your r by 2, what will be your y? That you need to put here. This is your equation 1. So y equal to under root r square minus r square by 2. So this will give you under root 2r square minus r square by 2 which gives me r square by 2 under root, or I can simply say r by root 2. So that means when x is r by root 2 and y is r by root 2, it means you are having this as your x. That means this is r by root 2, and if you will calculate AB, then it will become equal to BC. You put, this is 2x, so 2 into r by 2, this will be the value, and here again this is 2 into y, and what is your y? It is again r by 2. That means your AB equal to BC, and if adjacent sides are equal, this is a square. Hence we have proved that if it is a square, then it will have a maximum area.